Okay, so are we running? We're running. Welcome, everyone. So, Nick, this is a demo for 8.5, section 8.5 in the book, and this is a nasty problem. This is going to make you all cry. I gave you a few hints. Express in terms of cosecant x. You know how pretty much every other problem we've done, Maddie, has been sine and cosine works. And I've always said, try sine and cosine. Most of the time it works. Well, here's one of those not most of the times. Okay, so we're going to try to express it in terms of cosecant x. We're going to then set it equal to 0. That's our plan. So we want, or we could set it equal to 0 now for that matter. We can say 2 cotangent squared x plus 3 cosecant x minus 1 equals 0. So we want to be able to say that this right here, 2 times something plus 3 cosecant x minus 1 equals 0. And this something, cotangent squared x, is fallen out of favor. And the new popular kid in town is cosecant squared x. So, Mariah, what could I write here that is the equivalent of cotangent squared x, but in terms of cosecant x? Cosecant squared, rather, sorry. Say that again. I'm sorry, I couldn't hear you. You could do that, but remember, I'm trying to do it in terms of cosecant x. Tanner, what do you got for me? Oh, where are you getting that nonsense? Recall, where'd you start with? You said that that cosecant squared x equals, what was it? What is it on your sheet? 1 plus cotangent squared x. Daniel, is this what you're going to say as well? Okay. So cosecant squared x equals 1 plus cotangent squared x. But that won't work, will it? Because we just have cotangent squared x alone. But wait, what can we do, Tanner? We can write it in terms of cotangent squared. What is that? I just invented a new trig function. We can say cotangent squared x equals cosecant squared x minus 1. And you're right. So that was a really good call. So now we can say, and maybe I'll drag this down. I don't know. Nah, I don't need to. I'll write it up here. Whoa, it's alive. Things flying all over the place. Okay, so now, Tanner, you said that we can call this cosecant squared x minus 1, correct? Okay, and I concur, and you're right. So now let's distribute that 2 and go 2 cosecant squared x minus 2 plus 3 cosecant x minus 1 equals 0. So far, so good. And again, you don't have to take feverish notes on this if you don't want to. You can watch them on YouTube if you'd rather. Okay? So now we can go 2 cosecant squared x plus 3 cosecant x minus 3 equals 0. So far, so good? Jose, is that all right? Would you tell me if it's not? I just combined the -2 and the -1 here to give me -3. Put them in descending order. Cosecant x squared plus cosecant x to the first minus cosecant x to the 0. Really? People always forget 0, man. It's bad. Now, at this point, I really would recommend u substitution. You don't have to, but it just might clean things up. So let u equal cosecant x. Okay? Bless you, that was powerful. That was a man sneeze. I don't think I need that much space. I'm used to calculus. Okay, so then we can say max what in terms of u? Yes. Yes. Minus 3 equals 0. And you don't have to do the substitution, but a lot of times for students, it's just easier to say, oh, look, this is in what form? Jonathan? Quadratic. Yeah, this is in quadratic form. Look, Mom. It's a quadratic. Okay? So then you can say, okay, let's try to factor it and see what we get. We look only at the 2u squared. What do we get? 2 and u over here. What about over here? Nick, what's next? Yeah, 1u and 2u gives us 2u squared. Then we look only at the 3. We look only at the 3. What are the factors of 3? 1 and 3 prime number. We look at the negative. It tells us that one's positive, one's negative. Look at the positive over here as bigger. So that one would have to be positive. Does this work? Does this one work? Let's check it. We get 2u squared minus, no, plus 6u minus 1u minus 3. Bummer. No easy factors. By that, I mean real numbers, whole numbers. Not real numbers, whole numbers, integers. Okay, so we quit and go home, right? We're losers. No. We don't quit. What can we do instead? Mackenzie, what can we do to solve for this? What can we use? Hannah? Yeah, we can say A equals 2, B equals 3, C equals negative 3, and we can say, well, how did it go again? I can't remember. Yeah, that helps a lot, Daniel. Really good. Negative 3 over 2 times 2. Really, you don't have to say plus and minus, but people always do. That kind of annoys me. B squared, not B, come on. 3 squared minus 4 times 2 times negative 3 over 2a. Negative 3/4 plus and minus the square root of, what is that? 9. Watch your signs. Holy cow. 9 minus negative 24. Check me on that. I could be way wrong. Negative 3/4 plus and minus square root of 33 over 4. At this point, sadly, we should go digital. Yuck. Gross. Okay. What is this about? So we get U is about equal to how much? Somebody check that.
Oh, wait, no, hold on, hold on. Yeah, yeah.
Come on. Start punching numbers. Zane, what do you got? Pause. Yeah, okay, that'll work. I'll go for that. Zero equals 0.6861, or U is approximately equal to negative 2.1861. I agree. Daniel, are you okay with that? Okay, good. Now, at this point, breathe. Breathe. E-A-T-H-E. Breathe. And think about, Max, stay with it, and think about the domain of, okay, because remember, it's not you, is it? It's me. No, I'm kidding. I'm kidding. No, remember, U equals what? Cosecant x. So instead of U equals this, we have to say to ourselves, what color was I using before? Self? What color? I was red? Kind of. Mostly. I want to be consistent. Okay, so instead of saying U equals that, we say cosecant x is approximately equal to 0.6861, or cosecant x is approximately equal to negative 2.1861. Okay, now we got to keep going. You can't really check that in your calculator, can't compute that. So what happens in our calculator? What do we got? Nick, what do you got? Where do we go from here? We're trying to solve for x.
Oh, I would do 1 over.
Well, let's just start with 1 over sine x is approximately equal to 0.6861, or 1 over sine x is approximately equal to negative 2.1861. We've got to be a little bit careful here, because remember when we did the graph of cosecant? We got to be a little bit careful. Let's see what I can come up with. If I just go there, yeah. Okay. And you may or may not have this with you, but the graph of cosecant x. Okay, here it is, and I'll try to make it a little bit closer. Closer. So what did Zane get? So we're saying there's some angle that produces a ratio of 0.6 and of, what was the other one? I can't even remember. Of negative 2. 0.6 and negative 82. What's the problem here? You got error. You did on your calculator. You got error, right? What's the problem here? And this is where we can be really good algebraists. You know, we can rock that functioning and the quadratics and solve, and our math is perfect and our division is perfect. And this is where we've got to separate from that and say, wait, does my answer make sense? Okay? What's happening here? Zane, loud and proud. There are no values in the domain, or I'm sorry, in the range of cosecant between -1 down here and 1 here. And one of our solutions was like right in here somewhere, 0.6 or -0.6. That part doesn't matter because they're both covered. Okay? So you have to write in your solution, okay, even though mathematically 0.6 is a solution, we would reject it, or we'd say it's an extraneous solution that has no real validity because the domain, or the range, I keep saying domain, the range of cosecant x does not include any values between -1 and 1. And this is where you got to be sharp because it was right mathematically, but it's not right the other way, okay? Questions on that? Oh, does the other solution work? Is there a value for -2 down here? Yeah, lots of them. But we're only doing between 0 and 2 pi, so there's probably only one solution here. Okay, we're almost done. Let's get out of here. And that was tough. That was tough. How many minutes am I up to there, Mr. Hale? No, on the recording. Okay, that's fine. I'll keep it under 20. So, reject 0.6861 because it, maybe I'll go over here, because it is not in the, don't pack up, set of range values for cosecant x. Okay? So then we say, all right, we're doing good. 1 over, I should stay in red. We're staying 1 over sine x. So, I should go the other way. 1 equals -2.1861 times sine x. I just multiplied both sides by sine x. Then what? I divide both sides by -2.1861 equals sine x. X equals what? Tyler, do it. Arc sine. What's 1 divided by -2.1? Actually, you can do that. You can just put that in your calculator, and what do you get? -20. You did it in degrees? Oh, you punk. Change that to radian mode, Tyler. So x equals approximately, I should say approximately -0.4574 radians. Okay, then you got to go 2 pi minus that, and then you can get your solution. This will be online tonight if you want to watch it. We'll check 8.5 tomorrow. Actually, we got to check a bunch of stuff. Thanks, y'all, for listening. Have a good day.